Hello, good morning to MSc second year students of physics department. I'm Vamsi Krishna from the Department of Physics, AKNU, Rajahmundry. So I have completed the unit 1. Now I'm going to deal antenna arrays. Okay. So what is antenna array? Okay. So you have let us say this is assume that this is one array. Okay, this is another array, this is another array, means sorry, this is one antenna, this is another antenna, this is another antenna. This group of antennas, if it is placed in a linear way, then it is a linear antenna array. So this group of antennas is called an array. This group of antennas is called as a array. Okay, so now we are going to discuss about what is antenna array. So why we use this antenna array? Because in some communication applications, in some wireless communication applications, we need to have narrow beam for large distance communications. ఒకవేళ మీకు ఇప్పుడు ఒక వైర్లెస్ కమ్యూనికేషన్ అంటే మీరు అంటే ఇప్పుడు ఇక్కడ నుంచి సమ్వేర్ వీ హ్యావ్ టు కమ్యూనికేట్ సమ్ information. So for wireless communication application, we need to have narrow beam for large distance communications. Okay, so to communicate any information, so we need a narrow beam for a large distance communications, right? So it is possible by two ways. One is increasing the size of the antenna. The second one is using antenna array. Okay, there is a we can there is a two ways, there is two possible ways for communicating uh, some information for the large distances. Okay, so it can be possible by two ways, that is increasing the size of the antenna. The another one is using the antenna array. So if when comes to the antenna array, antenna formed by the multiple elements of antenna is a antenna array. Okay, so multiple elements of antenna means group of antennas. Okay, the group of antennas is called an array. Okay, so let us consider two antennas. Okay, A1 and A2, okay, are placed at the distance separated by the distance d. Okay, so this antenna, whatever the antenna placed at the A1, the antenna is whatever the antenna is placed at A2, these both are producing, means having the current equal in magnitude and phase. So this whatever the current having in antenna A1 and A2, having the both the current equal in magnitude and phase. So you want to find out the what the so consider the 2 points A1 and A2, both are separated by the supplied with current equal in magnitude and phase separated by the distance d. Okay, so consider a point P for away from the array. Let that the distance between the P and A1 be R1 and R2 respectively. So as this is the point R1, this is the point R2, so this is the point P, P2. So distance between A1 and R1 is is distance r1. The distance between a2 and somewhere p is equal to r2. Okay, is equal to r2. So let's say the this r distance r1 and r2 is equal to r. This r1 is equal to r2 is equal to r. Let us assume like that. Okay, so as these radial distances are extremely large as compared with the distance of the separation between the two point sources, that is d, then r1 and r2 is equal to r, assume like that. So the radiation from the point sources a2 will reach the earlier at the point p, okay, than the a1 due to the path differences. Okay, so let us say the electromagnetic wave is traveling in the form of the wave from the antenna A1 to the point P, and from A2 to point P. So there will be some path difference. So if we consider like this, I will redraw it. Okay. This is the phase phase angle with respect to the some reference plane. So you wish to find out the electric field, means electric field at a point P due to this antenna A1 and antenna A2 at some point P, but the distance between A1 and R2 and distance between A2 and R2 is equal to 2, but the radiation uh, what are the radiation coming from the both antennas, uh, the radiation from the point source A2 will reach the point P the earlier than the A2 due to the path difference. That path difference which is equal to path difference which is equal to d into cos phi. So I will show it in the material. Okay, so this is the path difference, this one. Okay, this is the path difference d cos phi. In terms of the wavelength, the path difference is equal to d cos theta cos phi divided by lambda. Then phase angle, then phase angle phi which is equal to 2 pi into phase path difference. 2 pi into, you have d into cos phi by divided by lambda. The phase angle phi is defined as 2 pi into cos, means 2 pi into path difference. The 2 pi into path difference which is equal to 2 pi cos phi, 2 pi into d cos phi lambda. Okay, so same that but the path the phase shift which is equal to the phase shift which is beta is defined as 2 pi by lambda. So substitute 2 pi by lambda which is equal to beta. Okay, then phi is equal to beta d cos phi. So let E1 is the far field at point P due to the source A1, and E2 is the far field at point P due to the source A2. So we are wish to find out the what's the electric field at a point P from the from the source of from the source antenna A1, and So we wish to find out the electric field at a point P from the source antenna A2. So that is E2. The far field components of at point P due to the point sources A1 and A2 should be summed up. So E1 is equal to E naught into e power of minus j, means phase angle divided by 2. E2 is E naught into e power of j phase angle divided by 2. The total field at a point P, which is equal to sum of the two electric field from the respective antenna sources. So if we add these two E1 and E2, then so multiply by 2 and divide by 2, then you will get a cos phase angle divided by 2. So we know that phi is equal to beta d cos phi divided by 2. Okay, so E Et is equal to 2 cos 2 E naught cos beta d cos phi by 2. So here E naught E2 E naught is the total amplitude of the field at a point P. So beta d cos phi divided by 2 is a phase shift. So equation 8 represents the total field intensity, total field intensity at a point at a at a, at P due to the 2 point sources having the currents of same magnitude and phase. Same amplitude or magnitude and phase. What is an error factor? It is a ratio of resultant field to the magnitude of maximum field. So when this the ET will be maximum, when cos 0 will be, if b theta means phase shift is equal to 0, if the phase shift means beta d cos phi divided by 2 is equal to 0, then cos 0 is equal to 1, then ET will become maximum. When it is ET, when will ET become minimum? Then cos 90 will be 0. Okay, then ET will be 0. Then so if beta d means phase shift is equal to 90 degrees, if the phase shift is equal to 90 degrees, then ET will be minimum. If the phase shift is equal to 0, then ET will be maximum. Okay, remember. So the array factor is defined as resultant field to the magnitude of maximum field. Magnitude of maximum field is 2 E naught. So ET divided by 2 E naught is equal to cos beta d cos phi by divided by 2. Okay, that is the array factor. The total field is total field in maximum direction. When it will be maximum? When theta is equal to, when means when phase shift is equal to 0, means when phase shift is equal to 9, the total field in maximum direction is the total field is maximum when cos beta d cos phi divided by 2, which is equal plus or minus 1. Beta d is equal to 2 pi by lambda, and we assume the space between the 2 point sources d is equal to lambda by 2. Then so we assume that lambda means d is equal to lambda by 2. So lambda cancel out, then you have only pi by 2 cos phi maximum, which is equal plus or minus 1. So when it will become plus or minus 1, pi by 2 cos phi maximum, which is equal to cos inverse of plus or minus 1, which is equal to n plus or minus n pi. Okay, if n is equal to 0, the cos phi maximum is equal to 0, then phi is equal to 90 degrees. Okay, the total field is minimum when the cos beta d cos phi divided by 2 is equal to 0. So beta is equal to 2 pi by lambda and d is equal to lambda by 2. Then so if we substitute the beta is equal to pi by lambda and d is equal to pi by 2 in the phase shift expression, you will get cos pi by 2 cos phi minimum, which is equal to 0. I think the total field, whatever the total field, it is the total field. So ET will be maximum when cos phi means phase shift should be equal to 0. Cos 0 is 90 degrees. So cos 0 is 1, right? So there is small mistake, I think so. The total field is minimum when phi is equal to 90 degrees. Total field is maximum when phi is equal to 0 degrees. So just rewrite means please recorrect it. Okay. Total power point direction when the power is of the voltage or current is 1 by root 2 times of maximum value. So phase cos of beta d cos phi by 2. So pi by 2 cos phi, which is equal to plus or minus 2n 2n plus 1 pi by 4. Then half power point direction, which is equal to 60 degrees or 120 degrees. So let us draw the graph between ET and phi, means phase angle, based on the results what we got in the previous one. The total field is maximum direction at theta is equal to 90 degrees. The total field is minimum in the direction. The phi is equal to 0 degrees. So according to that, draw the graph. Okay, thank you. I hope you understand what is antenna arrays. So why we use the antenna array? Because to increase, to send you any information for the long distance. So in a wireless communications, so we have to use the antenna arrays. Okay, ఇప్పుడు ఒక సమాచారం మనం పంపించాలి అంటే కనుక ఒక లాంగ్ డిస్టెన్స్కి, సో what we have to do is we have to use the antenna array or increasing the size of the antenna, then we can send the information from the transistor to the receiver, transmitter to the receiver. Thank you. So in next class I will explain the n elements linear array. Thank you.